Welcome to BTEC Revision. In today's lesson, we're looking at self-inductance. By the end, we should be able to calculate self-inductance, magnetic flux, or current. What is self-inductance? Self-inductance is the ability of the coil or circuit to induce an EMF in itself when the current flowing through it changes. And we can calculate self-inductance via this equation. Self-inductance equals the number of coils times the magnetic flux divided by the current. And the short form is L equals N times phi divided by I. And the units for phi is Webers, current is measured in amps, number of coils has no unit, and self-inductance is measured in henries, H for short. When the current through a coil changes, it creates a changing magnetic field around the coil. And if you remember about Faraday's law, according to Faraday's law of electromagnetic induction, this changing magnetic field induces an EMF in the coil itself. Hence the name self-inductance. Now, let's look at an example. If a coil has 500 turns, a magnetic flux of 0.02 Webers, and a current of 0.5 amps, calculate the self-inductance. We'll start by writing down our equation. L equals N phi divided by I. And we have N is equal to 500. Phi is equal to 0.02. And the current is 0.5. And this gives us a value of 20 henries. Now pause the video here and attempt this exam question. A coil has a self-inductance of 2000 millihenries. If the current through the coil changes at a rate of 0.5 ampere per second, calculate the magnitude of the induced EMF. Let's start by writing down our equation. L equals N phi divided by I. And since the question is asking for induced EMF, we also need to use our equation from last lesson. EMF equals minus N delta phi divided by delta T. Looking at what we have self-inductance, 2000 millihenries. We have the amps per second. Okay, so what we'll have to do is we'll have to combine these two equations. And since we want EMF, we'll take this one and we'll somehow plug this one into the second. We can see if we rearrange the first equation here for N phi, that would give us Li equals N phi. And that we can replace over here to give us EMF equals minus N phi is Li divided by our time. And our time is combined here with the current, which is 0.5 amps per second. So we have this value over here. And now we can just plug in our values here. So minus self-inductance, which is 2000 milli. So that's times 10 to the power of minus 3. And we have current per unit time. And our value here is current per unit time. So that would be times 0.5. And this gives us a value of minus 1. And the unit is volts. And that's the end of the lesson. If you'd like to boost your grades, visit us at btechrevision.com with lots more resources. See you next lesson.